Welcome back, everyone. Today we're going to talk about graphing quadratics in factored form. Now, there is a separate method for graphing quadratics in vertex form. That is not the topic today, but that was one of the previous topics in lesson 2. So if that is something you're interested in, there is a video on that as well. But let's talk about today graphing quadratics in factored form. So when it comes to factored form, there's two main points we know right away. In most cases, assuming that there are two solutions for each factored form equation, which sometimes there is just one, but generally there's two. Right? We know those two zeros really easily. So those are two very obvious points for us to graph. The other point that we certainly need is the vertex, right? It wouldn't be good enough to just plot 2 points and not get the minimum and maximum value accurate, right? To not get that accurate and to not have it necessarily open up in the right direction either could be the other problem. So it's very important that we still get the vertex accurate and then the other 2 points accurate, and we have a pretty accurate drawing in that case. So I'm going to just jump into an example here. Here we have an example with this quadratic of y equals -1, x minus 3, x plus 2. So first things first, I would like to find the zeros. So I'm going to set y to 0. 0 equals -1, x minus 3, x plus 2. And going back to what we learned in the very beginning, what are our two x values? What are our two values that will get this whole thing to be 0? Right? So x is 3 and x is -2 are the answers. Now, how do we know that? Well, the thing is, we're multiplying three things together. We're multiplying -1, we're multiplying x minus 3, and we're multiplying x plus 2. And if any one of those three things is 0, 0 times anything is 0. And so if one of the things we're multiplying here at any point is 0, then it's a true equation. Everything is 0 from that point forward. And so if we plug in x equals to 3 into this equation, we end up with 0 times -1 times 5, which is 0. Or if we plug in -2, we end up with -5 times -1 times 0, which is 0. And so both of these two answers work, and no other answers will work, right? It's also, likewise, it's impossible to choose a different value for x that doesn't make any of the three things we're multiplying together 0 and still get 0 as our answer. Now, we could get something very close to 0 doing that, but we don't care about close to 0. I want exactly 0, not just something that's close to 0. So these are our two answers. So I'm going to plot these points right away, 3 and -2. And I am going to label my graph somewhat. I'm not too worried about labeling the graph as much as getting the points accurate, but in order to know that we got the points accurate, we do need some labels on our graph, so I will somewhat label it. I am going to put a little bit of effort here into the labeling. Okay. Next, we need to find the vertex. So right off the bat, we have a negative value, -1 as our A, so we know the parabola opens down and there is a maximum. So we're expecting the vertex to be up here somewhere, right? Up in this section somewhere. I don't know exactly where, but somewhere up here. Of course, it's not enough to just randomly draw one and hope it's the right vertex. We actually have to find the vertex, which we have done previously. So to find the vertex, we need to find H and K. So to find the x-coordinate of the vertex, which is also known as h, we need to find the average of the zeros. So the average of the zeros would be 3 plus -2 divided by 2, which is 1 over 2. Okay, so there's our x value. And then to find the y-coordinate of the vertex, to find our k value, we're going to plug in that 1/2 as our x, and use that to find y. So here we have -1 times -2.5 times 2.5, which let's see what that is. It's 6.25. Okay, so therefore our vertex is 0.5, 6.25, and I'm going to draw that here as well. So 0.5, 6.25. So probably somewhere around there, kind of covering up part of my labeling, but that's all right. Okay, and then I'm just going to draw the graph from there, going through all 3 points and opening down as expected. Good. All right, let's try another one. This one has very similar methods, so I do encourage you to pause the video, go ahead and give this a try if you feel comfortable with doing that, and come on back when you're done. All right. So for this one, same method as before. This is exactly the same type of question as before. First thing I'm going to do is find the zeros. So it's very easy to say that the zeros would be x equals to 1 and x equals to 5. So I'm going to draw those right away, 1 and 5. And again, I probably should, label at least some points on my graph here. So I will do that quickly. -2, -4, -6, -8, -10. Okay, good. All right, so then to find h, we find the average of the x, the average of the zeros, or the average of the x-intercepts. So h is equal to 1 plus 5 divided by 2, the average of 1 and 5, which is 3. And then our k value is, we're going to just plug in 3 for x to find it. So we end up with 2 times -2, which is -8. So therefore our vertex is 3, -8. So let's find that. 3, -8 is right there, and the parabola opens up, right, as expected, because that a value, which is the 2 right here, this very first number here, is positive, so we do expect it to open up and have a minimum. Like that. All right, very good. All right, so 2 more questions involving this topic. This one says, find the equation in factored form that of the parabola that has a -2 and 4 as x-intercepts, which say it's same as zeros, and passes through the point 2, 16. All right, so let's do that. Let's figure that out. So we know that all factored form equations have this form: y equals a times x minus s times s, or x minus t, where x and y is any point on the parabola, and s and t are the zeros. So I'm going to sub x equals 2, y equals 16, and I'm getting that from this point here, is how I got those numbers. I know that this is a point on this graph. And then for s and t, s is going to equal to -2, t is going to equal to 4, and I got this from here, the fact that the parabola has x-intercepts as -2 and 4. That's how we know that. Now, it doesn't matter which one is which one is s and which one is t. No, it does not. We really do not care. I could put t as -2 and s as 4, and we would still get the same answer. So it really doesn't matter. The goal here is to find the a value, because we don't have this full equation if we don't have the a value. If I just put in my s and my t value and I still leave a, well, there's a million, or, not a million literally, but actually more than a million. There's infinitely many parabolas that have -2 and 4 as their zeros. However, there's only one parabola that looks exactly like this. There's only one possible parabola that has the point 2 and 16 and also has these zeros, right? So it's important to keep that in mind. That just the zeros is not enough to determine the equation of the parabola. We need the a value too, because otherwise it's just a generalized parabola that could really be any parabola that just has those zeros. Very good. So let's do that. Let's solve for a, and then we'll write the equation with the a value in there too. So y is 16, we said. A is, well, we don't know what a is. That's the whole point of doing this, is to figure it out so we have the full equation. X is 2 and s is -2, so -2. And then we have x again, which is 2 minus t, which is 4. So this is 16 equals a times 4 times negative 2. So that means negative 8a equals to 16. So a is negative 2, which that looks about right. If we look at this parabola, that sounds about right to me, right? It's going to be negative, and this does look like a skinnier parabola than our parent function parabola of y equals x squared. So this sounds about right. Good. So now I just need to write the equation. It says find the equation in factored form. I just found the a value, so I need to just rewrite this as y equals negative 2 x minus s, which is really x plus 2, right? The negative and the negative ended up giving us a plus, and x minus t, which was 4, and this is our final answer, right? So this gives us a very specific parabola with just the a, without the a value, just by saying a, it could mean a whole bunch of, it could mean infinitely different, many parabolas. So it's important to find the a so that we know the full equation, because the three elements of a full factored form equation are the two zeros, or the 1 0 if there is only one, and the a value. That's what we need to get that factored form equation. All right, here's another one that's very similar. It says find the equation in factored form of the parabola that has negative 7 and negative 1 as x-intercepts and passes through the point negative 4, negative 9. So again, I encourage you to give this a try if you are comfortable doing that. And yeah, when you're done, we'll get back to it. But it's the exactly the same as before, exactly the same methods that we tried previously. Okay. All right. So with that said, let's get into it. So again, we know that all factored form equations have this: x times a, x minus s, x minus t. And we know in this case that x is equal to negative 4, y is equal to negative 9 is a point. Of course, there's many other points, but this is the point we know, so this is the point we'll use. And then s equals negative 7, t equals negative 1. So there's those, and I've got them from these as the zeros or the x-intercepts. And then I'm going to plug all these numbers in, find the a value, and therefore know that third element of the equation we don't know, and be able to write out the equation. So let's do that. So y, which is negative 9, that's equal to a times negative 4 minus negative 7 times minus 4 minus negative 1. So negative 9 equals a times 3 times negative 3. So negative 9 equals negative 9a. So a equals 1. Alrighty, so therefore, the equation is y equals x plus 7, x plus 1, right? Because the negative 7 here and the negative 1 here, they just make pluses. And then we could put 1 in here, but the 1 is invisible. We also can just not include it. But yeah, we did it. So actually, in this case, if someone forgot to find the a value and just left it blank, they would be right. But don't count on that always happening. Of course, that's not always going to necessarily be the case. So do make sure you still find the a value. Make sure it really is 1 before you just forget about it and leave it blank. All right, well, that's everything for this chapter. We have one more thing to discuss, which is linear quadratic systems, and that will be next time. I also have some suggested practice problems for anyone who does want to practice more of this on their own time. So the suggested practice problems for this one are these here, right? The graphing quadratics in factored form is right here in 3.7. And they're page 192, number 1, 4a and b, 7, 8, and 14. And so those are the recommended problems for today. Thanks again, everyone, and we will see you back next time. Bye for now.